In this video, I'm going to hit some of the basic algebra properties that you need to know in geometry. These are only the properties that are essential to geometry, and the names might vary slightly from previous courses, but they are the same properties. The first property is the addition property of equality, and you'll notice there are some abbreviations we'll be using in class for the properties. You're allowed to use the abbreviations. And it states that if A equals B and C equals D, then you can add the same value to both sides of an equation and it should remain balanced. So A plus C equals B plus D. Next property is the subtraction property of equality, which lets you subtract the same quantity from both sides of the equation. In some textbooks, they don't really have a subtraction property of equality because you can think of adding a negative, and therefore that sort of makes the property obsolete, but we do have this property. We're going to use it just to kind of specify if we're adding a quantity or subtracting it from both sides of the equation. We're not going to abbreviate this one because we don't want it to get confused with substitution or symmetric. Then we have multiplication and division. Multiplication, multiply both sides of the equation by the same quantity, the equation remains balanced. Division, same thing. Where C does not equal 0 because you don't want to divide by 0, or D is not equal to 0. Distributive property lets you distribute across addition or subtraction. You can also use this property backwards to factor. And pull out a common factor like so. And we'll still call it the distributive property. Substitution lets you plug in a value. So for example, if we know what A is, we can plug it into A here. And let's actually say that this 2A plus 1 equals 7. And so if that is true, then we can say 2 times 3 plus 1 equals 7. So plugging in a value, we do this with a system of equations. When we want to solve it, we'll use the substitution technique. Reflexive is saying that something is equal or congruent to itself. This is also reflexive. Even though the letters are backwards, you're talking about the same segment. So it's congruent to itself, which is sometimes confused with symmetric, which is about flipping the equation. So if 2a plus 3 equals 7a minus 5, then 7a minus 5 equals 2a plus 3. If angle 1 is congruent to angle 2, then we can also say that angle 2 is congruent to angle 1. And the last property that we're going to be using when we write geometry proofs is transitive property of equality. It's kind of like a chain reaction property. It says if A equals B and B equals C, then A equals C. If you notice, you're kind of lining up these variables that are the same variables and then kind of just removing them and talking about the ends, kind of like a chain reaction or a sandwich, and you're talking about the bread or the outer variables. We can also do this with congruence. We can say if angle 1 is congruent to angle 2 and angle 2 is congruent to angle 3, then angle 1 is congruent to angle 3. And then I'm going to work through one algebra proof. So our goal is going to be to solve this equation and justify all of our steps. The first reason is just that this is the given problem that we want to solve, the equation that we want to solve. The most likely used second step would be to then distribute, which was already done. So this is distributive property. There's not a formal abbreviation. You can abbreviate as long as it's pretty clear which property you're using. Next step, I'm going to combine like terms. So I've got negative 4x plus 6 equals 16 minus x. We can call that substitution. So substituting in place of negative 6 and positive 12, when you combine those, you're replacing that with a positive 6, or you can just call it the process of combining like terms. Step 4, we're going to move the variables to the same side of the equation. So I'm going to say 6 equals 16 plus 3x. I used addition property of equality, and to both sides I added 4x. You don't have to show that step, or you could try to squeeze it in or write it horizontally. But it is common practice not to show this step because you've communicated here what you did. Next, I'm going to subtract from both sides, so subtraction property of equality. And I'm going to subtract 16, so we'll be left with negative 10 equals 3x. And finally, I'm going to do the division property of equality to get that x equals negative 10 over 3. I've also, in the same step, in addition to dividing both sides by 3, I did flip the whole equation. So if I do a kind of 2 moves at once, and one of them is a small move like flipping the equation, I would just put division property of equality and symmetric property. You don't always know how many steps. It just worked out that it came out exactly to however many steps I had set up here, which was 6. Somebody might do this and it might take 7 steps, or it might take 5 steps. As long as you're justifying all of your steps, I wouldn't be as worried about how many steps it takes you, as long as you have all of your work there and all of the correct reasons. So this was a quick overview of the properties of algebra that will show up in geometry. A quick example of writing an algebraic proof, and there's more examples on Blackboard, including this one below if you want to check out another one. And then quickly hitting some examples and the names of the properties, which were, you need to know transitive property, you need to know symmetric reflexive, and then the 4 properties that deal with the 4 operations, as well as the distributive property and the substitution property.